Now the next question is a little bit more simple than it appears. If you draw your first card, it's either going to be a club, a heart, a spade, or a diamond. And regardless of which suit you pick first, if you're going to draw a second card that's going to be the same suit, well then the probability of same suit then, since it's going to depend on what was drawn first, is going to be equal to the number of outcomes. So there were 12 cards left in whatever suit was picked first and 51 cards in the deck. So the probability of two cards being drawn and they're both in the same suit then will be approximately 23.5%. Now, the next question, and you'll notice that number 6 and number 7 are very similar in their wording. I'm going to answer number 7 first because we're going to use that answer in order to determine number 6. Now, 2 dice are shown. What is the probability of throwing a 4 on the first die and a 3 on the second die? Well, these are independent events because the result on one die is independent of the result on the other. So the rule for finding probability of independent events is the probability of A and B is equal to the probability of A times the probability of B. And so this is 1/6 probability of rolling a 4 times 1/6 probability of rolling a 3 on the second die. And that outcome, or sorry, that probability is 1 in 36. And this makes sense because if you remember doing the grid where we had 36 possible outcomes, only one of them was a 4 on the first die and a 3 on the second die. Now, going back up to this number 6, it says, what is the probability of throwing a 4 on the first die or a 3 on the second die? And again, I got to emphasize when we have or, automatically you got to ask yourself, is this mutually exclusive or non-mutually exclusive? Now, the question is, can you roll a 4 on the first die and a 3 on the second die? And the answer is yes. We just saw that down in number 7. So since this is non-mutually exclusive, then the rule for that, or the way we calculate this, is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So this is for non-mutually exclusive. And I'll write that up there. So this is non-mutually exclusive because we can have both events occurring. So this is going to be, probability of A is 1/6. The probability of rolling a 3 on the second die is 1/6 as well, minus the probability of A and B. Well, we answered that down in number 7. That is 1 over 36. And so this is equal to then 11 over 36. Again, so 11 divided by 36 will be about 30.5 repeating percent. So it's approximately equal to 30.6%. Number 8, A piggy bank contains 2 quarters, 3 dimes, 4 nickels, and 5 pennies. One coin is removed at random. What is the probability that the coin is a dime or a nickel? And again, we have to ask if this is mutually exclusive or non-mutually exclusive. And since you can't, if you're drawing out one coin, you can't draw out both a dime and a nickel. So this is a mutually exclusive event. Or these are mutually exclusive events. So the probability of A or B is just, for mutually exclusive events, is the probability of A plus the probability of B, which is equal to, now we've got 3 dimes, 4 nickels, 2 quarters, and 5 pennies, so a total of 14 coins. Now, of the 14, 3 of them are dimes, so 3 over 14, plus the probability of drawing out a nickel is 4 out of 14. So this is 7/14, which is a half, which you should have been able to see that this is equal to 50%. So you have a 50% probability of drawing out either a dime or a nickel if you're removing a coin at random.